So now we're on to our last skill in this unit, and that's adding and subtracting rational expressions. So we know what a rational expression is, we know how to simplify them, we know how to multiply them, how to divide them, and the last is we're going to learn how to add and subtract them. And just like in the last lesson, when we're going to start with what we do with regular rational numbers, and we're going to apply that to our rational expressions. So by the end of this lesson, you should be able to add rational expressions and simplify them, subtract rational expressions and simplify, and state restrictions. So let's start off with this first example with just rational numbers. So we have a half plus 3/4. If you're going to work ahead, what I'm actually going to do is I'm going to change one of these numbers. I'm going to change this 2 to a 3. So I'm just going to do that now before we move forward. So hopefully you remember how to do this from elementary school. But when we add fractions and subtract them, what makes it a little bit harder than multiplying and dividing is we need to make sure that our denominators are the same so that we can add the numerators and the denominator will remain the same. So when we're adding fractions, we always have to look for the lowest common denominator. So we usually do this by listing all the multiples of each of the denominator and seeing which one is lowest that they have in common. So if we lift the multiples of 2, we know it's 2, 4, 6, 8, etc. The multiples of 4 are 4, 8, 12, etc. And that means that our lowest common denominator is going to be 4. So we have, in this fraction, the denominator is already 4, so we don't have to change it. But in this fraction, we're going to multiply both the numerator and the denominator by the same number. The reason why we can do that is because by multiplying by 2 and then dividing by 2, we're really multiplying by 2 over 2, which is the same thing as multiplying by 1. So we're not actually changing the problem. So now if we simplify, we have 1 times 2, which is 2, all over 2 times 2, which is 4, plus 3 over 4. Now our numerators are the same. Sorry, our denominators are the same. They're both 4. We can add the numerators. So we have 2 plus 3, which is 5, all over 4. And we cannot reduce it because there's no common factors in 5 or 4 other than 1, so we're done. So now let's move on to another example where we're going to subtract. I've changed that 2 to a 3, so now we have a third minus 3/4. So once again, we're going to start off by finding the lowest common denominator. So now the denominators aren't multiples of each other like they were here, so we could get away with just multiplying one of the fractions. Here we're going to have to list out the multiples of 3 and list out the multiples of 4 and figure out what the lowest common multiple is, or a quick way to do it is just multiply the 3 and the 4 and we're going to get 12, and that will also give us a common denominator. So now that we've got our LCD, we've just got to figure out what to multiply our numbers by. So we're going to multiply this guy by 4 and by 4, and again that's just like multiplying by 1, by 3 and by 3. And let's just quickly simplify this. So we've got 4 over 12 minus 9 over 12. And we're going to be left with negative 5 over 12 as our final answer. So I went through those examples really slowly because we're going to follow those exact same steps when we're applying it to rational expressions. So when we had number examples, the first thing that we did was look for a lowest common denominator. So now our denominators are polynomials, and one of the polynomials is x plus 2 and the other is x minus 3. So we need to find the lowest common multiple between both of these. So we're going to look for the lowest common denominator. And the easiest way to do that is just to multiply both of these. So the lowest common denominator is going to be x plus 2 times x minus 3. So I'm going to quickly rewrite this just so that I have enough room. And I'm just going to put a space between the fractions. So we have x minus 3. So the nice thing is because we made the lowest common denominator the product of both of these denominators, we can just ask ourselves, what do we have to multiply this denominator by to make this this LCD? So this denominator already has the x plus 2, so we just need to multiply it by this other one, x minus 3. So I'm going to multiply it by x minus 3 at the bottom, and just like in the numeric example we have above, we've also got to multiply it by x minus 3 at the top. Really, we're just multiplying by 1 because x minus 3 divided by x minus 3 is just 1. Now let's look at the next one. This denominator is x minus 3. So this is taken care of. We just need to multiply it by x plus 2. So we're going to multiply x plus 2 in the denominator and x plus 2 in the numerator. Now if you take a look, these denominators match. In this denominator, I have x plus 2 and x minus 3. Same with here, just in a different order. I have x plus 2 and x minus 3. So if I were to rewrite this, I have in the numerator 4 times x minus 3 all over x plus 2 times x minus 3. And then plus, now I have 2 times this guy. So plus 2 times x plus 2. All over, and I'm just going to write them in the same order I have here. So I'm going to put the x plus 2 first, then the x minus 3. So all over x plus 2 and then x minus 3. So now it's really clear that these two denominators are the same. Therefore, we can add the numerator and leave the denominator alone. So in the numerator, we have 4 times x minus 3 plus 2 times x plus 2. And then all over x plus 2 times x minus 3. So now it is so tempting. I see an x minus 3 and an x minus 3. It's so tempting to cross those out. However, this numerator is not factored. I have a plus here. So if it was factored, it would look like this. A factor times a factor. Here I have a factor times a factor plus another factor times another factor. So these aren't actually factors at all. So what we have to do is we have nothing to do in the top except simplify. So there's nothing in common between these two terms. So really all I have left to do is actually distribute this and see if maybe I can factor it once I collect all the like terms. So I have in the denominator I have x plus 2 and x minus 3. In the numerator I've got 4x minus 12 plus 2x plus 4. That will simplify to x plus 2, x minus 3, and I have 4x plus 2x, which is going to make 6x, and I have negative 12 plus 4, which is going to make negative 8. So I can factor this actually, so what they have in common is 2, so I'm just going to rewrite this as 2, then I'm going to have x minus 4, all over x plus 2, x minus 3. So now that it's factored, I can take a look if there's any common factors in the numerator and the denominator. Unfortunately, there's not, so I'm done. So these two rational expressions added together just simplifies to this rational expression as long as we include our restrictions. So starting up at the top, we have x can't equal negative 2 and x can't equal 3. And keep on going to make sure we haven't missed anything. Negative 2 and 3. 3 and negative 2, and they're all going to continue that way, so we are done. So now let's try some more examples. So we've got two more rational expressions we're going to subtract. Start off by finding the lowest common denominator, and the denominators don't include any variables, so it's very easy. The lowest common denominator here will be 12. So I'm going to add some brackets to our numerator because we're going to be multiplying these guys. So I need to multiply this denominator by 3, and as well as the numerator by 3. I'm just going to put the 3 in front. And I'm going to multiply this next denominator by 4. So multiply by 4, and I'm going to put the 4 in front here. So let's simplify this. In the numerator I have 3 times 4x minus 3 all over 12. Minus 4 times x plus 2 all over 12 as well. And now we can add those numerators. So we're going to have 3 4x minus 3 minus 4x plus 2, and then all over 12. So the numerator isn't factored, so we can't cross out any common factors in the numerator and the denominator. So all we have left to do is just expand this numerator so that we can factor it. And so we're going to be left with 12x minus 9 minus 4x minus 8 all over 12. And let's keep simplifying. We're going to be left with 8x minus 17 all over 12. Trying to factor this numerator, there are no common factors, so we are done. This expression simplifies to this one right here, as long as we include the restrictions. And let's take a look. So up here, there are no variables, so there's no x in the denominator, so then there can't be any restrictions. As same if we continue down, there's no variable in the denominator, which means that there are no restrictions at all in this expression, so we are done. In the next example, if we take a look at both of these, the denominators already match. This denominator is x minus 2 as well as this one, so we can go ahead and right away add these numerators together. So we're going to have 4 plus 3, which is going to make 7, all over x minus 2. And that's our final answer. So we have this expression simplifies to this one here, as long as we include our restrictions. This one will have restrictions because we have x's in the denominator. So here restriction is x can't be 2, as well as here, as well as here. So our only restriction is x can't equal 2. And in this next example, this is slightly different. These look so similar, but they're not exactly the same. And we cannot add or subtract a fraction unless these numerators, the denominators are exactly the same. So this looks like something similar that we looked at previously, where it looks so close to the other expression, but slightly different. So let's just take a look at this guy, and we're going to bring him over here and see if we can rearrange this so that they do look more similar. So I'm going to rearrange this so that the x is listed first. I'm going to write negative x plus 1, and then I'm going to factor in a negative 1, so I'm left with negative 1x minus 1. And when I put it back, something beautiful will happen. I have 1 over x minus 1, and I've rearranged it and factored it, and I know that 1 minus x is the same as negative 1x minus 1. So now both of these denominators have a common factor, and that's x minus 1 and x minus 1. So when we make our lowest common denominator, my lowest common denominator then is negative 1 x minus 1. The reason is because I can make this denominator look like this denominator by just multiplying by negative 1. So I'm going to put a negative 1 over here, multiply this by negative 1. Therefore, I also have to multiply my numerator by negative 1. And this denominator is already negative 1 times x minus 1, so I don't need to do anything to it. So let's simplify this. In the numerator, I have negative 1 times 1. That's going to be negative 1. All over our denominator, we have negative 1 times x minus 1, which now matches our other denominator. And therefore now I can subtract these numerators. So I have negative 1 minus 1, which is going to be negative 2 all over negative 1 x minus 1. So my numerator is factored because it's just one number, and my denominator is factors. Here are the two factors. So I can just take a look at the numbers here and reduce them. So negative 2 divided by 1, that's just going to be 2. So I have 2 all over x minus 1. And there's my final answer. So I have these two expressions subtracted just simplifies to this one expression, 2 over x minus 1. We've got to include our restrictions. In this case, our restriction is that x can't equal positive 1. So we're going to work on some slightly more complex ones. So take a look at these two denominators and see if you can come up with the lowest combination of factors that we can make our lowest common denominator. So this is what I mean. So our lowest common denominator, well, take a look at the numbers. I've got a 2 and a 5, and I know the lowest common multiple of 2 and 5 is going to be 10. And they both already have in common an x, so I know I can include that in my denominator. So just taking a mental check, can I create 10x from each of these denominators? Well, this one, 2x, just needs to be multiplied by 5. So I'm going to multiply this one by 5 and this one by 5, and we're going to get 10x. And this denominator just needs to be multiplied by 2, multiplied by 2, and multiplied by 2. And it's also going to create 10x. So in the numerator, I've got 3 times 5, which is 15, all over 2 times x times 5, which is the same thing as 2 times 5 times x, which is 10x. Then plus, I have 4 times 2, which is 8, all over 5 times x times 2, which is 5 times 2 times x as well, so it's 10x. And now our denominators match. So I can add the numerator, so I'll be left with 23 all over 10x. And if I take a look at these numbers, there's no common factor of 23 and 10, so it can't be reduced, and we're done. So all we have to do is add a restriction. So here we can see that x can't be 0, x can't be 0, so that is our only restriction. And we are done. We are on a roll now, so let's keep it going. Here, again, we're adding two fractions, so we have to make sure that our denominators are the same. So let's look for a lowest common denominator. So we're going to look for the combinations of factors that's going to make our lowest common denominator. So we have two factors here. We have a 3 and we have an x minus 2. So let's just combine those two. So I'm going to use 3 and x minus 2 because they're all different factors. So I'm just going to rewrite this so I have space for you to add in your polynomials. So then I have plus 5 over x minus 2. Okay, so taking a look at this is what we want and this is what we have. So I already have the factor 3, so I can just now multiply by the x minus 2. So in the denominator x minus 2 and also in the numerator x minus 2. And I'm going to have this denominator here. This one's just missing the 3, so I've got to make sure to put this in brackets, and I'm going to multiply it by 3 and by 3. And so now the denominators will match. So I will have in the numerator 2 times x minus 2 all over 3x minus 2. Then I have plus, I've got 5 times 3, which is going to be 15, all over, then I'm going to bring the 3 in front just so it matches the other denominator, and I have 3 times x minus 2. And ta-da, we have our denominators are matching, therefore we can add those numerators. So we are going to have 2x minus 2 plus 15 all over 3 times x minus 2. The numerator is not factored, the denominator is factored, so don't expand this because we're just sort of working backwards. We want it always factored so that we can cross out any common factors. The numerator is not factored because we have this plus 15, so let's expand this and we will have 2x minus 4 plus 15 all over 3x minus 2. And when we simplify, we will have 2x plus 11 all over 3x minus 2. We have to check if we can factor this numerator because maybe they have something in common, but we can't. It can't be factored. So we're done as long as we include our restrictions. So we have no restrictions here because there's no variable. Here our restriction is x can't equal 2. So we're going to add that and let's continue checking. X can't equal 2, no restrictions, and we've got all of them. So we are. So this one's another simple one, so try this one on your own and come back to check to make sure that you've set it up correctly. So find your lowest common denominator and then multiply your fractions by whatever you think they need to be multiplied by, and come back to the video and check. So the lowest common denominator is just a combination of the two, which is x and y. So this fraction just gets multiplied by x and this fraction just gets multiplied by y so that they will have that denominator in common. So we have the denominator xy, and in the numerator we have x times x plus 2 minus, again in the denominator we have xy, and in the numerator we have y times y minus 2. So we're ready to combine these two. So we're going to add those numerators. So we have x times x plus 2 minus y times y minus 2 equal to, we're going to expand this because we need to factor this numerator. So we have x squared plus 2x minus y squared plus 2y all over xy. There's nothing more to simplify in this numerator, so we're done. We're going to add in our restrictions that x can't equal 0 and y can't equal 0, and we are done. So for this next example, I want to make it slightly harder, and I'm going to add a third rational expression. I'm going to go plus a. So now we have not one, not two, but three denominators, because I know I can always change this plus a to over 1. So now let's come up with our lowest common denominator. So that's going to be our lowest combination of factors. So we have one factor, which is a plus b, so we've got to include that one. So we have a plus b. We have another factor, which is b, so we've got to include this one as well. And we have a third factor, which is 1, which is always included here anyways, it's just invisible. So for example, I can put a 1 here and it doesn't change it at all. So now that I have my lowest common denominator, I'm just going to rewrite this so that I've got space to add in my factors for you to see. So 2 over b, and then I have plus a. Okay, so this denominator needs to be multiplied by b so that it matches. So we're going to multiply by b on the bottom and b on the top. We have this denominator already has a b, so it needs to be multiplied by a times b. So sorry, a plus b, so times a plus b times a plus b. And this denominator is just over 1, so it's missing the factors of a plus b and b. So we're going to multiply this by a plus b and b, a plus b and b. And now all the denominators are going to be a plus b times b. So in the first fraction we have 4ab all over b times a plus b, plus in the numerator we have 2 times a plus b all over b times a plus b, plus in the numerator we've got a times b times a plus b. I'm just going to rearrange it. So we've got a plus b all over b times a plus b. So now all of our denominators match, so we know we've done this right, and we're ready to just add those numerators. So in the denominator we have b times a plus b. Don't expand that because it's already factored. So in the numerator we have 4ab plus 2a plus b plus ab a plus b. So the denominator is factored, the numerator is not, so we have to factor that. Sorry, we have to expand that in order to factor it, to see if we have any common factors. So we've got to expand first. So we've got 4ab plus 2a plus 2b plus a squared b plus ab squared all over b times a plus b. So carefully look through here and see if we have any like terms. We have an ab and a b, an a squared b, and an ab squared. So we've got no common terms. We've got no like terms. We can't add or subtract anything, simplify. So we're done as long as we include our restrictions. So we have a restriction here. We can either write in terms of a or in terms of b, and we have a restriction here for b. So I'm going to write that b cannot equal 0 because we can see here b can't equal 0. If it is, then it's going to be 2 divided by 0, and that answer is undefined. Here I have a new restriction. So I'm just going to write a little note, restrictions, and it comes from a plus b also cannot equal 0. So I could either isolate for the a here or the b here. Since I've already written one in terms of b, I'm just going to do both in terms of b, but you could isolate in terms of a if you wanted to. So I'm going to bring that a over, and I'm going to say b cannot equal negative a. So we have a second restriction, which is b can't equal 0, and it also can't equal negative a, and that comes from right up here. And the b can't equal 0 comes from here. We've got no other additional restrictions, so these are our only two, and we are done. Okay, we've got 2 problems left, and these are the big ones. You can do it. So I have this complicated rational expression plus this other complicated rational expression. So far the expressions that we've seen have already been factored for us. So the denominators have already been factored. So choosing the lowest common denominator is very easy because we just combine all the factors. Here we need to figure out what the factors are first, which means we need to factor it. So I'm just going to list our 1 and 2, and we're going to factor it on the side. So try it on your own and then come back to the video to make sure you factored correctly. So now that we've got the denominators factored, it should look something like this. Our first expression factors to w plus 4, w plus 1, and our second factors to w plus 4, w minus 2. So now that we've got our denominators factored, we can start looking for the lowest common denominator. So it's just going to be a combination of these factors. So we've got 2 factors here, 2 factors here. So one factor that we have to include is w plus 4. So I'm going to include that, w plus 4. And our next factor is w plus 1. So we have to include that as well, w plus 1. And if we take a look at our other denominators, we have w plus 4. We already have that one included. So that's in common to both. So we don't need to add a second one to our lowest common denominator. Then we have w minus 2, that's a new one. So we have w minus 2. So now what we need to see is what are we going to multiply these denominators by to get this lowest common denominator. So taking a look here, we are missing the factor of w minus 2. We have the w plus 4 and the w plus 1, they're here. We're just missing a w minus 2, so that's what I'm going to multiply this fraction by. So make sure you've got brackets in the top. So I'm going to multiply, I can't really squeeze it in there, so I'm just going to sort of multiply it underneath, but I'm going to multiply this denominator by w minus 2, and also in the numerator, I'm going to multiply it by w minus 2. Okay, and this next denominator has w plus 4 and w minus 2, so it's missing the w plus 1. So I'm going to multiply this denominator by w plus 1, and this denominator by w plus 1. But how I've written it, it just looks like I'm multiplying 3 by w plus 1. But it's this entire binomial, so I'm going to make sure that that's in brackets. So if I rewrite this now, in the numerator we have 3w minus 4 multiplied by w minus 2. And then I've got, let's make that shorter, then I've got plus 2w minus 3 times w plus 1 all over these 3 factors, w plus 4, w plus 1, w minus 2, and then the same in the next expression. Okay, so both of the denominators match, so we can rewrite them. If you're ready to skip some steps, looking ahead, we know that we are not going to expand these denominators. We're going to leave the denominators exactly how they are because it's already factored, and we can check if we have common factors in the numerator and the denominator because it's all factored down here. Up here, when we add these two, because we're adding them, they're not going to be factored, so we're going to need to expand it. So I'm going to FOIL to expand these. And so I'm just going to sort of FOIL as I put them down into the next line. So I'm going to do 3w times w, which is 3w squared. Then I have 3w times negative 2, which is negative 6w. And I'm going to continue. Negative 4w. And then I have negative 4 times negative 2, which is plus 8. And then I have plus this FOILed. So I have plus 2w times w is 2w squared. Then I have 2w times 1, which is 2w. And then negative 3 times w, which is negative 3w. And finally, negative 3 times 1, which is negative 3. So now we've got a bunch of like terms in the numerator that we can collect. So we've got a big numerator. In the denominator, we have w plus 4, w plus 1, and w minus 2. So taking a look in the numerator, we have 3w squared plus 2w squared, and that's going to make 5w squared. Then we've got negative 6w minus 4w plus 2w minus 3w, which is going to give us negative 11w. And then we're just left with plus 8 minus 3, which is going to leave us with plus 5. So now we just have to check if we can factor this numerator now that we simplified it. So we'd have to factor this by decomposition. So we're looking for two numbers that multiply to 25 and add to negative 11. And unfortunately, there are no numbers that satisfy this, which means we're done as long as we include our restrictions. So there will be restrictions on W, so we'll say W can't equal, and let's take a look up here. When it's not factored, it's near impossible to tell, so let's take a look at when it's factored. So no, W can't equal negative 4, negative 1, negative 4 we've already got, and positive 2. So we have negative 4, negative 1, and positive 2. And if you continue down, we haven't added any new factors, so everything stays the same. So this is our final simplified expression with these three restrictions. You have made it to the last example. We are here. Keep pushing. We are almost done. So we've got 1, 2, 3 rational expressions. None of them are factored, so we can't tell what the greatest or the lowest common factor is. So factor them, find your lowest common factor, and multiply your fractions, then come back. Okay, so hopefully you factored your denominators. The first one factors as a difference of squares, so we have x plus 2, x minus 2, or in the other order. The second and third one, they're just common factoring, so we have x times x plus 2 and x times x minus 2. So now for the fun part, let's find that lowest common denominator. So let's make a combination of these factors. So we have two factors here, x plus 2 and x minus 2, so let's include those ones. So we have x plus 2 and x minus 2. Looking ahead, we have a new factor, which is x. We haven't included that, so let's include that in our lowest common denominator. And then we have x plus 2, which we've already included here. Next, we have x, already included in x minus 2. So actually, with these three denominators, there's only 3 unique factors. So those are our factors. We just got to figure out, what is this guy missing? Well, this guy's missing the factor of x. So we're going to multiply by x in the denominator and x in the numerator. In the next one, this guy is missing the factor x minus 2, so we're going to multiply by x minus 2 in the denominator. We're going to put brackets around this and multiply by x minus 2 in the numerator. And last, this denominator is missing x plus 2, so we're going to multiply by x plus 2 in the denominator and in the numerator, and make sure we put brackets around this binomial. Okay, so let's plan here. Our denominators are all going to be the same. They're all going to be x plus 2, and x minus 2. So I'm going to write that as a common denominator. X plus 2 and x minus 2. And then we have our numerators. Our first numerator is going to be x squared. Then we have a minus, and then we have x minus 2 all squared, and then we have a plus, and then we have x plus 2 all squared. And again, it's always so tempting to just cross these off, but remember, we're factored in the denominator, we're not factored in the numerator. So we've got to expand these guys, collect like terms, and then see if we can factor and cross out. So what I'm going to do is similar to what I've done here. I factored on the side. I'm going to expand these two binomials on the side. So I'm going to expand this binomial and this binomial just over here. So let's expand x minus 2 squared, and let's expand x plus 2 squared on this. So this first one is just going to expand to x squared minus 4x plus 4. And the next one is going to expand to x squared plus 4x plus 4. So if you need to take more steps to do that, then do so. Start to train yourself to reduce the number of steps of these sort of simple skills that we did in grade 10. So see if you can start to visualize what our A, our B, and our C is. Even if you can't do it now, let it be something that you work on or work towards. So now that we have it expanded, we're going to put it back into our equation. So we have x squared minus, I'm going to put into brackets. We know what this x minus 2 all squared is. It's just this trinomial here. Don't forget the minus though. We've got to distribute that negative in there later. So we've got x squared minus 4x plus 4 plus, and now we have x plus 2l squared, which we know is this trinomial here. X squared plus 4x plus 4 all over our denominator, which we're not going to expand because it's already factored. The only reason we're expanding this, guys, is because it's not factored, so we got to simplify it. So in the numerator, one more time, we've got x squared minus x squared plus 4x minus 4. I've just distributed this negative 1 into the bracket, and then I have plus x squared plus 4x plus 4 all over our denominator. All right, so let's collect those like terms, and we're done. So we have x times x minus 2 times x. Oh, I've lost a plus here. So plus 2, x minus 2. Okay, so we have x squared minus x squared. Those are going to cancel out, and we'll just be left with 1x squared. Now for the degree 1 terms, we have 4x plus 4x, that's going to make 8x, so plus 8x. And then we have minus 4 plus 4, that's going to make 0. So we can actually factor this numerator one more time. We can pull out an x, and we're going to be left with x times x plus 8 all over x plus 2, x minus 2, and we are done. Unfortunately, there's nothing in common in the numerator or denominator, so we can't cross it out. However, let's just add our restrictions, and then we are really done. So what can't x equal? Starting up at the top, not factored, not helpful. So here we've got x can't equal negative 2, x can't equal 2, and x can't equal 0. So we have 0 or plus or minus 2, and we are done.